Hello everyone and welcome to today's Leostream webinar, Remote Access for All, an Introduction to Leostream. My name is Jamie Sullivan. I'm the Marketing Manager here at Leostream, and today I am thrilled to be joined by our own Leostream CEO, Karen Gondoli. Here at Leostream, we are often told by our customers that one of the best parts of working with us is working with our team. We will be the first to admit we are not a behemoth like VMware or Citrix, not even close, but sometimes the best things come in small packages, and when you work with Leostream to build out your remote access solution, most of the time it means you'll get to work with Karen. So before we get started, I want to take a moment to actually introduce you to her. Karen holds a Bachelor of Science and a Master of Science in Aerospace Engineering from the Massachusetts Institute of Technology. For the rest of us, that means she is an actual certified rocket scientist. The technology we work with here at Leostream, though complex, is not rocket science. However, if it were, she would be able to handle that too. Karen joined Leostream in 2006 as a technical writer after taking a small break from her technology career to pursue her passion for pastries. Although she has found technology to be her true professional calling, trust us and our waistline, she still has quite a talent for baking and is not only CEO, but is also head of office birthday cakes. Karen has worked her way through the Leostream ranks from technical documentation writer all the way to CEO, and for a very good reason. In her over 10 years at Leostream, she has seen nearly every use case for VDI, desktops as a service, on-prem environments, cloud environments, and she has played an essential role in building out the Leostream solution to support them all. Finally, I would be remiss if I did not mention, on top of all of her professional achievements, she is also an avid marathon runner. She has completed over 50 marathons and is very close to having completed one in every state. So if you are in the U.S., she has likely completed one in your state too. So be sure to ask her about it. She's got some great running stories. And with that, I'm going to turn the presentation over to Karen.
All right, thanks, Jamie. That was fantastic. And thank you all for joining us today. This is an exciting webinar for me personally because it really focuses on Leostream. I spend a lot of time talking about our partners and the industry, and this time it's all about us. Who is Leostream? What does the platform we provide do for you? And most importantly, what does Leostream 9 look like and what's new? Those are the things I'll cover in this webinar. And like Jamie said, I'll save a little time at the end for Q&A. So let's get started with a little bit on who we are. Leostream is a software company on a mission to be the premier platform for providing remote access to hosted IT assets. We don't care if those assets are your VMs on your favorite virtualization platform, instances running in a public cloud, or physical workstations in the data center. We focus on connecting users to their allocated assets and remain vendor neutral when it comes to where you host those assets and what display protocol you use to connect to them. Not only does that vendor neutrality allow your organization to build a VDI environment tailored to your needs, it helps us focus on solving the really difficult problems related to managing complex business workflows. Leostream has customers around the world in all the major verticals, from financial services, where we manage large trading floor environments, to healthcare, where we allow doctors with proximity cards to log on and off of desktops when they enter and leave a room without having to touch the login screen. We support engineers in the oil and gas field, connecting them to their workstations using pixel-perfect display protocols that allow them to pinpoint exactly where to drill. And we also support visual effects engineers, connecting them to the video editing tools that make your next favorite movie. You'll find Leostream users in the aerospace and automotive industries, in semiconductor design, and even in the universities that train all those engineers. Because our platform is so flexible and open, its applications are endless. Leostream is the go-to platform for enterprise-grade remote access, no matter the vertical. But don't take my word for it. Our customers speak for us. Because we're not just about providing a product, Leostream is about customer service. Our platform is complicated, we get that. But we're not going to let you struggle because of it. The emails that make my day come from customers who rave about our support staff. As Jamie mentioned, we're not behemoths like VMware and Citrix. And the plus side of that is that we're more agile and more willing to work with and for you. Our customer successes are our successes every step of the way. Finally, I'd like to give a shout out to some of our partners. Leostream is just one piece of a complete hosted desktop solution. You need to host your desktop somewhere. You may need a profile management tool. You definitely need a display protocol to connect your users. Our goal is to give you the flexibility to build the hosted desktop solution that's best suited for you. So we partner with industry experts who provide the other bits and pieces you'll need. Here you see just a selection of the technologies we integrate with, from public and private clouds like AWS and OpenStack, to Linux solutions like SUSE, to hyperconverged systems like scale computing, and the list goes on. Leostream's name is widely known and respected around the industry, and we work with our partners constantly to strengthen our integration and solve our customers' problems. Okay, enough about the company. Let's look at the remote access platform that we provide. The Leostream platform consists of 4 components. The first is the connection broker. It's the brains of the operation. You install it onto a Linux machine, then configure it using the administrator web interface. In that web interface, you'll define the pools, plans, and policies that model the business workflows you need to implement in your hosted desktop environment. On the hosted desktops that you're managing, you'll install our Leostream agent. It's a small component that runs as a service on Windows or as a Java application on Linux, and is responsible for monitoring the user's remote session. Leostream Connect, then, is our software client. It allows you to turn any client device into a Leostream client. Finally, there's the Leostream Gateway. It's the newest addition to our family and provides gateway functionality for network-isolated desktops, as well as a built-in HTML5 viewer for clientless access. So let's start looking at how all those pieces fit together. To start, let's look at an on-premises environment. In this case, your Leostream connection broker and your hosted desktops are all located on the hosting platform of your choice, be that Azure, vSphere, Scale Computing, what have you. Users and their client devices communicate directly with the connection broker to log into your Leostream environment. The connection broker receives the user's credentials, authenticates the user against your chosen authentication systems, and then, based on who the user is and where they're logging in from, the connection broker offers the user a Leostream policy, which indicates which pools the user has access to. When the user requests a connection to a desktop, the connection broker hands the desktop connection information back to the client device, and the display protocol makes a direct connection from the client to the hosted resource. At that point, the connection broker's job is done. Now it's just waiting for notifications from the Leostream agent, like if the user's gone idle or disconnected from their session. Note that in this architecture, the connection broker doesn't sit in the data path of the desktop connection. That means you get the native performance of whatever display protocol you decide to use. And the broker doesn't act as a single point of failure in the user's connection. Looking more closely at the Leostream components in the on-premises diagram, first and foremost is the connection broker. It's your single pane of glass for managing users and their IT assets, no matter where those IT assets are hosted. Leostream's provisioning capabilities are particularly well suited for hybrid cloud environments, giving you ways to automatically provision and delete desktops to meet demand, even letting you create schedules for spinning up and terminating instances, so you can avoid sprawl and large compute costs associated with it. Beyond our comprehensive pooling capabilities, we also provide a wide assortment of plan and policy options that allow you to model just about any VDI workflow you can think of. Yes, we provide persistent and non-persistent desktops, but we can do every shade in between and beyond those workflows as well. Finally, because the connection broker is the control center of your environment, it knows everything that's going on and it logs it. That gives you one location to retrieve audit-level tracking of who's using what, from where, and for how long. That not only allows you to track asset usage, but can also help you plan for capacity in the future. The other component in our on-premises diagram is the Leostream agent. It monitors the user's remote desktop session for events like operating system logins and logouts, session disconnects, and more. You can use those notifications in the connection broker to build rules that control the user's session and desktop, such as automatically logging them out after they've been idle for 2 hours. The agent also has a role in the connection broker's provisioning capabilities. It's responsible for a set of sysprep type actions, like updating the newly provisioned VM's hostname and joining it to the domain. Lastly, the agent is responsible for Leostream's last mile end user experience features, like attaching network printers to the remote VM or controlling USB device pass-through. Okay, now let's move beyond your premises. What does Leostream look like if you have remote users? Here's where we introduce the Leostream Gateway. It lives in a location that is network accessible by your remote users and by the desktops. Those desktops are isolated in a network that is not otherwise accessible by the user's client device. Maybe users are at a coffee shop connecting back to your data center. Or maybe they're in their office and connecting to a virtual private cloud in AWS. The concept is the same. Tuck your desktops in an isolated network and then use the Leostream Gateway to tunnel the display protocol traffic from the user's client to those desktops. The Leostream Gateway also acts as a tunnel for your Leostream login traffic. Note that My Connection Broker is located in the same isolated network as the desktops to ensure successful Leostream agent and connection broker communication. Now, no matter if your users are on-prem or remote, they can log into Leostream environments using the Leostream web client or Leostream Connect. Which client they decide to use can be based on if you want to provide web-based clientless access or if you need some of the other end-user experience features available in Leostream Connect. With this diagram in mind, let's look more closely at the final two components of the Leostream platform. First, a little more detail on Leostream Connect. It's an application that provides login access to your Leostream environment from Windows, Linux, and macOS devices. It's important to understand that Leostream Connect handles the login process, but it's not part of the final desktop connection. Leostream Connect obtains the user's credentials and passes them on to the connection broker. The connection broker then returns the user's list of offered desktops based on the user's policy, and Leostream Connect displays that list to the user. The user selects a desktop to connect to. Leostream Connect grabs the connection configuration from the connection broker. Then, and this last step is important, Leostream Connect launches the software client associated with the user's display protocol using the connection configuration from the connection broker. That means when the user is connected to their desktop, not only is the connection broker not in the data path, neither is Leostream Connect. So if, for example, the user connects using Mech9 TGX, then Leostream Connect launches the TGX receiver and connects it directly to the TGX sender on the remote machine. The only time Leostream does get in the path of your desktop connection is when you use the Leostream Gateway. The gateway tunnels the user's connection from their client device to their remote desktop. It can tunnel high-performance client-based protocols like TGX and also provides a built-in HTML5 client that can launch RDP, VNC, or SSH connections inside your browser. I make one last point on this slide about rogue users. In Leostream, a rogue user is someone who logged onto one of your hosted desktops without going through Leostream. As long as your desktops have installed Leostream agents, your connection broker knows who those users are and what they're connecting to. So let's say you want to keep rogue users out. In that case, isolate your desktops in a network that isn't accessible from the user's clients and direct users to log into Leostream so you can tunnel their connection through the Leostream Gateway. Now rogue users are simply unable to connect to the machines. All right, so now the part that you've all been waiting for, let's see that all in action. So here you're seeing the login screen for the Leostream Connection Broker Administrator web interface, and I'm going to log into it as the default administrator. Now I will mention that this login screen is completely configurable through a CSS file, so you can change colors, logos, layouts, whatever you want. If you haven't seen Leostream 9 before, this is the new layout for our Connection Broker web interface. It's basically menus along the left, and what we generally tell people is you're going to start at the top and work your way down to connect us to your external systems and also configure your VDI workflows. Let's start in Setup, where we're going to talk to all of our external systems. The first thing you want to do is connect us to your authentication servers. Leostream supports a number of different types of authentication servers. Obviously, we support Active Directory and see that often used, but we also support different types, such as anything based on OpenLDAP, even old NIST servers if you're using Linux, and something that's new is support for SAML-based identity providers. Using the SAML support, you can actually use systems such as Ping Identity or Okta and leverage the multi-factor authentication that they provide. After you configure your authentication servers, you want to hook us up to your external hosting platforms. That's done in our centers. Again, because Leostream is vendor neutral, we support a wide range of different center types. And any center type you see on here, we integrate with using the native APIs that they provide. Obviously, you see different clouds, you see OpenStack, different virtualization platforms such as VMware and Red Hat, and also hyperconverged systems such as scale computing. As soon as you create your centers, Leostream reaches out to those hosting platforms and inventories the desktops and images you already have. Those appear in the Resources section. Any page you see in Resources is generally just a laundry list of everything that you're managing within your connection broker. So for example, on the Desktops page, I see all the different virtual machines or physical machines that I'm managing connections to. While on the Images page, I see all the images that are available for me to provision new machines from. After creating centers, the next system I want to integrate my broker with are any gateways that I'm using. The Leostream gateway also installs on Linux, and it's a separate Linux machine from your connection broker. And then pretty much after you install it, you don't need to do any configuration on it. You simply come to the gateways page in the connection broker and register your gateways with your Leostream connection broker. The last thing I'll point out in the setup area is that one of the new things we now provide is integration with different types of MFA providers. Now, currently, this is limited to Duo security, so you can use push notifications as a second factor of authentication in Leostream. We do support Radius for multi-factor authentication, and it's set up somewhere different in the connection broker. We'll move it into this section in the next release of Leostream. These MFA providers, you can then associate them with different groups of users, so you can have different users logging in using different providers. After you configure all your setup, now you want to move into the configuration section. And this is where you're defining all the different VDI workflows that you want to manage in Leostream. The first thing you want to do is build your pools. Pools in Leostreams have a few functions. One is pools are simply organizational. So you can actually arrange your desktops based on maybe the way that you connect to users, maybe based on the platform that they're hosted in, basically any way that works for you as the administrator so you can sort and manage your machines. The other purpose for pools is provisioning. So for example, if I look at that pool, if I look at this pool, you'll see the way the pool is set up is at the top I define how desktops should be sorted into this pool. And in here I'm basically just saying anything that's part of my scale cluster that has my initials in it. And then down here I can actually start provisioning new machines. So what this allows you to do, and this is very useful in cloud environments, is to actually have a pool with a limited number of machines in it and then actually spin up a set of machines all at once. So I can do batch provisioning. I can even do that provisioning based on the time of day. So if I know I have users logging on a Monday at a certain time, I can actually just schedule machines to be created at that time and then tear them back down when that time frame is over. The rest of the provisioning parameters are then specific to the hosting platform you're using and basically give Leostream the information it needs to spin up the correct machine associated with the appropriate network and also indicate if it's deletable. Obviously, we want to be careful not to delete machines that aren't part of your Leostream environment. So we force you to actually mark them deletable. Now, the other part that we can do, I mentioned that the Leostream agent has a little bit of sysprep functionality, and that's controlled by this domain join section. Here's where you can say, well, if the broker finds a machine that's not part of the domain, should I automatically join it to the domain? If so, which domain? Potentially put it in an organizational unit, and set the host name if I want. So that's the second purpose of pools, to control provisioning and allow you to automate when machines are created. The third purpose of pools then is obviously to assign desktops out to users, and we'll show you in a minute how that's done via policies. Now, when a user is offered a desktop from a particular pool, you need to decide how do you want to connect the user and how do you want to manage their remote session. That's done through what we call plans. The first plan here is the protocol plan. This tells the broker how to connect your user. As I mentioned, we support a wide range of different display protocols, and you'll notice that this form is broken up by sections. So here's my Leostream Connect client. I can connect users using a certain set of protocols when they log in from Leostream Connect. I can change the protocol that they're offered when they log in using the Leostream web browser. The next two plans, power control and release, here's where you start to see where the Leostream agent comes into play. So if I look, for example, at a power control plan, here, if you notice, it's broken into these sections based on events. Did the user disconnect? Have they logged out? Did they go idle? These are the events that are coming to the broker from your Leostream agent. And when you get those events, you can schedule these types of actions. So for example, this power control plan says, well, when I get a logout notification, I want to immediately shut down the machine. This control of the power state is another thing that's important in cloud environments, because as soon as the machine's shut down, you stop incurring the compute costs. So the power control plan controls power state, straightforward enough. Release plans, here's where you can actually start modeling those persistent versus non-persistent and everything in between workflows that I mentioned. For example, let's look at this plan, deleting on logout. Here again, you see that the plan is broken into sections. Did the user disconnect? Have they logged out? If I read through this plan, what it says is, well, after the user logs out, wait 10 minutes. Maybe they want to log back in really quick. But if 10 minutes go by, I'm going to release the desktop to the pool. That basically breaks the assignment from the user and then actually triggers this section of the plan. The important thing to realize about these Leostream plans is they cascade. So one event will trigger the next section. So my logout triggered a release, which then is going to invoke this option to delete the machine. So if the machine is marked deletable, the broker will reach out to the hosting platform and attempt to delete the machine. Again, good in cloud environments, helps you to remove compute to save costs, also helps you build environments where you have single-use desktops. So the user logs in, gets their machine, does their job, and then the machine goes away. And through pools and provisioning, a new machine is spun up for its place. So far we've created our pools, we've built some plans, now we need to bring them all together in what we call policies. A policy is simply a set of rules that says, what pools do I offer machines out of? How many desktops should I offer out of that pool? And then there's a number of other rules in here that help the connection broker choose which particular desktop should it pick out of the pool. For example, can we offer stopped machines? And if we do, we'll power it on before offering it to the user. Finally, then, you actually take those plans that you've built and associate them to the pool. Now you'll notice that this one policy actually offers desktops from multiple pools. So you can actually mix and match operating systems, display protocols, and make sure that the user always has access to whatever it is that they need. That's done throughout policies, because what you'll see is that a user gets a single policy. So the policy needs to offer multiple pools if that's required. Before we talk about how those policies actually get applied to users, we need to quickly discuss locations. A location in Leostream is similar to a pool, but whereas a pool is a group of desktops, a location is a group of clients. And the nice thing is you can change the policy the user has based on where they come from. So using locations, you can change their offers, change their display protocols, and do a few other things. So for example, the way I have this set up is I say, well, anyone who's logging in on premises, they're using our Leostream Connect client. So I've created a location for Leostream Connect. Then I have another location, which is everybody logging in from a web browser. These are the clientless access people who are logging in remotely from my coffee shops. So that's all my configuration. Now I want to bring it all together in the assignments table. This is where I'll finally say, hey, what policy do users get? Now, if you remember back to the setup section, the first thing I did was create authentication servers, and I had two set up there, one for Leostream and one for our dev environment. You see those same two rows here. The broker automatically adds rows here every time you add an authentication server. And then I can come in and edit the rules for that authentication server here. Now the way this reads is it says based on who the user is, and by default we use the user's member of attribute in Active Directory, but you can change that to a different attribute if you want. So based on who they are and where they come in from, those locations we created, I give the user a role and a policy. The policy determines their pools and the plans associated with those pools. The role, it has limited effect on end users. It can do things like say, hey, should we give them permission to reboot their machines? But what it is actually more useful for is providing role-based access to this entire interface that we've been stepping through. The role allows you to turn on and off different pages, even turn it on and off different features on a page. So for example, if you have a set of desktop administrators that should only see that desktops list in the broker and only be able to reboot machines, you can use the role to restrict them down to that. Now, when a user actually logs in, what happens is the broker finds them in their authentication server, authenticates them, and then goes to the assignments table for that authentication server. And we start stepping down the rules until we find the first rule that the user matches. So if I have a domain user logging in from a web browser, the broker will follow through the first 2 rows and assign the user to the 3rd row, the RDP remote users. Now obviously, there's a lot of configuration options here. So before users actually start logging in, I want to test to see if that's what's really going to happen. You can do that using our handy little test login feature. So if I come here to the users list, here I'll see all the users who have logged into my Leostream environment. But even before somebody logs in, I can do a test login. So let's see what happens when I log in from a remote client. I'm going to run the test, and this shows me the logic the broker will use on the login. You see it found me in my authentication server. It looked up my member of attributes because that's how my assignments table is set. And then it started stepping through the assignment rules. As I mentioned, I didn't match the first 2 and finally matched the 3rd. So I get a user role and a policy. Below that, I see the logic that the broker is going to take based on the policy to ultimately offer me a machine and show how I'm going to be connected. Now, notice that the way I'm going to be connected is through the HTML5 viewer because I logged in from a web browser and I'm considered a remote user. One thing I'm going to point out, and this is kind of subtle, this is my broker's IP address, 3790. Here, I see the same login page as I saw before, but now notice my IP is 3770. That's the IP address of my Leostream gateway. What I'm doing here is I'm tunneling the user's login traffic through the gateway because they're a remote user on a web browser. And then ultimately, I'm going to launch the connection in the browser as well. So let's sign in. There's that machine that I was offered in the test login. And now I'm just going to connect. That's going to launch the browser-based connection through my gateway. And you'll see that there. Now, while that's going on, if I come back to the administrator web interface, you see everything that's going on in the broker here in the log page, as I mentioned. So notice here in this line, I successfully logged into the browser, was offered a machine, requested the connection, that assigned me to the machine, and now that I'm assigned to that machine, it's mine, nobody else gets it. And it launched the connection. As soon as I was assigned, well, my pool was set to automatically provision new machines so that the next user who logs in has access to a machine as well. So my assignment then triggered provisioning, and now this new machine is being spun up in my scale computing environment. Finally, you notice that I was logged in, so the Leostream agent sent a notification that I'm logged in there. On the desktops page, now what I see is I see myself assigned, and so now you can come to this page and see who's using what. And I can even click the status link here to see that I'm logged in. And just in case I've been logged in for a while and have forgotten to log out, the administrator can go in and forcibly log the user out using the Leostream agent. So hopefully that gave you a good idea of all the different platforms we integrate with and all the different workflows you can model in Leostream. Before we wrap up though, I want to point out a few aspects of the Leostream platform that are harder to demonstrate. And those have to do with scalability and reliability, things that are very important to the enterprise. When you build a proof of concept with Leostream, you can install a single connection broker and use its internal database to hold your Leostream configuration. But when you move into production, you want to consider the amount of load on your Leostream environment and how you want to handle failover. Remember that I said the Leostream connection broker isn't in the data path of your user's connection. That means in Leostream, load isn't measured by the number of simultaneously connected users, it's measured as the number of simultaneous user logins. A single connection broker can process about 5 user logins per second with no discernible delay to the user. So what if you have 1,000 users all logging in around 9 a.m.? What do you do then? Well, in order to scale your Leostream environment to handle enterprise-level logins, you build what we call a Leostream cluster. A Leostream cluster consists of multiple individual connection brokers all attached to a common external database. You can use Microsoft SQL Server or Postgres, depending on which your database team prefers. All connection brokers attached to the same external database act as a unit, working off a common job queue that processes user logins, center scans, and any other Leostream jobs. So if you have a cluster of 3 connection brokers, now you can process 15 logins per second, and you see how that scales. Clusters also provide high availability for your Leostream environment. In a clustered environment, if one connection broker becomes unavailable due to a network issue or hosting platform failure, the other connection brokers in the cluster continue to process user logins and any other jobs in the queue. You can also model workflows in your clusters to support disaster recovery scenarios. For example, you can spread your desktops and connection brokers in your cluster across multiple data centers, and then direct users to the primary or DR data center, depending on whether a failover event has occurred. So as you probably noticed, Leostream is a very flexible and powerful platform, and I just barely scratched the surface here. But my time is up, so I'm going to wrap up and hand it back to Jamie.
Thanks so much, Karen. To get started with a 30-day free trial of Leostream, please be sure to visit us at leostream.com. If you fill out the free trial form, the sales team will be in touch with a trial product key. Thank you again for joining us for today's webinar presentation, and enjoy the rest of your day.